One of them, Jupiter's moon Europa, turned out to have a vast ocean of liquid water under its icy exterior, a fact that instantly made it a target for scientists interested in finding life away from Earth. Since that early discovery, such interior oceans have been found on other Jovian moons, on Enceladus, a moon of Saturn, and perhaps even under the frozen surface of Pluto. Instead of being a rarity found only on Earth, liquid water appears to exist in many other places, even within our own solar system. The paradigm that told us that water has to be in surface oceans, as on Earth, was just wrong. Things got more curious as we started exploring the outer reaches of our system. We'll touch briefly on the silliness involved in the demotion of Pluto in Chapter 4, but the fact of the matter is that Pluto is actually the gateway to a whole new part of the solar system. Called the Kuiper Belt after the Dutch astronomer Gerard Kuiper, 1905 to 1973, who suggested its existence in 1951. This is a flat disk of material that extends out beyond Pluto. We have known about the belt for a long time, but it was usually considered a kind of afterthought to the inner planets. Indeed, one of the authors of the audiobook you are listening to, James Trefil, hereafter JT, once compared it to a scrap pile left at a construction site after the important building was done. This attitude changed quickly when astronomers discovered that, far from being an inconsequential pile of rubble, the Kuiper Belt is actually home to an incredible variety of planets. Some of these planets are the size of Pluto, and some even have moons. Today, some astronomers estimate that dozens of planets may be lurking out there, a number that completely dwarfs the familiar inner group that includes Earth. Even before we left the solar system, in other words, the simple paradigm of 9 planets orbiting the Sun was breaking down. Instead of being a lonely, demoted outsider, Pluto became the beginning of a previously unknown collection of worlds. The search for exoplanets. Our search for planetary systems circling other stars has a long history. We'll discuss the daunting problems involved in this search in Chapter 3. Even so, as you might guess, when we finally nailed down the existence of such a system in 1992, the discovery came as a complete surprise. The new planets, which are indubitably there, turned out to be circling the wrong kind of star, a kind of star called a pulsar. Pulsars are small, unbelievably dense, rapidly rotating masses of matter left when a large star explodes in a supernova. These supernova events mark the end of the line in the evolution of some types of stars. The titanic explosion blows huge amounts of material out into space, and you would expect that any planet unfortunate enough to be in orbit around such a star would be completely destroyed. Yet, here these planets are, where no planet ought to be. If the pulsar planets were the first surprise, the detection of planets circling normal stars was the next. The technique originally available for exoplanet detection, described in detail in Chapter 3, involved measuring the small motion of the star ascribable to the gravitational pull of its planet. Such a technique is best at detecting large planets, those capable of exerting strong gravitational pulls on their star. Someone observing our own solar system with this technique, for example, would see the effects of Jupiter before he or she, or it, saw the effects of Earth. In any case, when this technique was used to search for exoplanets, the first positive results were the discovery of what came to be called hot Jupiters. These are massive planets, typically several times larger than Jupiter, orbiting close to their stars, often closer to their stars than Mercury is to ours. But according to the paradigm that other solar systems should be like ours, this was impossible. Gas giants such as Jupiter were supposed to form only far away from their star, not close in. Another surprise? Another failure of the paradigm. As the collection of hot Jupiters grew, astronomers began to wonder if any system out there is like ours. As it turned out, they need not have worried. The fact that we were finding hot Jupiters first was simply a result of the detection system available. The situation changed with the launch of the Kepler satellite in 2009. We'll describe this incredible instrument in more detail in Chapter 5, but basically it searches for the small dimming of a star's light due to the passage of a planet.